orthographic projection. So let us begin with the topic. So what is the purpose of sectional views? So let us see. So first, clarifying the views by reducing or eliminating the hidden lines. And second purpose is to reveal the elements of the cross section. So here we will be cutting the object in order to reveal the maximum information as possible. This is our basic aim. And we will be minimizing or reducing the total number of hidden lines of an object for better clarity. And the second main objective of sectional views is facilitate the dimensioning. So sometimes it is seen that we are having numbers of hidden lines, we can't give the dimension to the hidden lines. So in this case, if you try to have the section generated of that particular object, then we can clearly identify the object and we can give dimensions very easily. So these are the basic purposes for giving the section. So these are the basic purpose for sectional views. So now let us begin. So first, let us see one example to get the advantage of this sectional view. So here we will be having one object. So this is suppose my three-dimensional object and these are two views. So this is the top view of the object and this is the side view of the object, or you can see the front view of an object. So when we try to observe the object from the top direction, we have this view generated, and when we try to observe this object from the left hand side direction, this is the view generated. So this is your top view and this is your front view. Now what we need to do? So here as you can see, there are not many details which are shown by the hidden lines. So it does not clarify the actual dimension of an object, and there are a number of lines, so it is not clarifying the actual shape of that object. So what we should do? So we should cut the object in such a way that it can reveal all the required information. So let us understand. So let us suppose if we take one cutting plane and if we try to cut the object like this, if we remove the certain portion away from the front direction, then we can now clearly see the real object like this. And then we can easily identify this object by converting these hidden lines into a solid line. In this picture you can see there is a better clarity of an description of an object. So we can easily define our object by removing the number of hidden lines, and we can clarify the objects like this, right? So this is nothing but your top view of the cutting plane. So this is your cutting plane. So if I observe this cutting plane in the object from the top view, then it will be shown like this line in the center of your view. So by cutting this object from this direction, I can reveal the information of an object like this. Now what is the benefit? Now after cutting the object, I have said that we can reduce or eliminate the hidden lines or the dotted lines. It is obvious. We have placed or replaced this cut section by hatching lines. Second benefit, we can give dimensions easily to the object now. So let us see the dimensions. I will be giving the dimension to this object like this. So here I can give this dimension also because it is clear. I can clearly observe this thickness of that object. I can clearly observe which is the element present at a particular location. So I can give this dimension to this circle. I can also give the dimension of the exact center of the circle from your leftmost side edge. So these are the benefits of having sections into your orthographic projections. So now let us define certain things like cutting plane. So cutting plane is a plane that imaginarily cuts the object to reveal the internal features as we have seen previously. So here we will be having one object once again. We will try to cut this object like this by cutting plane as you can see. So by cutting we can reveal the internal features of an object. It is very obvious. We can now see the internal details and the complex geometry of that object by cutting that object. So let us define few of the things in the cutting plane. So this is known as the cutting plane. This is known as the section lines, and these are usually drawn at 45 degrees and spaced equally between each other. And this edge or vertical top edge is known as a cutting plane line. So we are showing that line into our orthographic projection by red line, which we have seen previously. You should plot this cutting plane line onto your drawing in order to show where we have cut the object from. Right? So let us move ahead. Now let us define the cutting plane lines. What do you mean by cutting plane line and what it its importance. So cutting plane line is the edge view of the cutting plane. So when you try to take the top view of the cutting plane, it will be what your cutting plane line. So this is our object, and these are some views of the object. So this is nothing but the top view of the object. So when we try to observe this object from the top, it is seen like this, and when we try to observe this object from the left hand side, it is seen like this. So you can see that there are two holes here shown. One is a square hole and second is a circular hole. And as these holes are not clearly seen, so it is shown by a dotted line. And we are not sure where is the center of that hole and what is the actual dimension of that hole. And is it the hole or what, we can't identify. So what we are doing is we are trying to cut this object by cutting plane line. So here the cutting plane line, the top surface of this cutting plane line shown by this straight line is used in order to show the cutting plane by this line. So this is nothing but it is generally used to show the path of your cutting plane or the position of the cutting plane on your object. So that's why these cutting plane lines are usually used. So after that we will be removing the portion, and after removing the portion we will be eliminating this dotted line and we will be making these lines as a darker like this, you can see. And after eliminating line we can now put the edging. So edging shows that we have cut the certain amount of material from that part, so that's why we have shown the edging. So now we can clearly identify these are the two cross section of your square hole, and this is the cross section of your circular hole. Now section line. So what do you mean by section lines? Section lines or cross edging lines are used to indicate the surfaces that we have cut by the cutting plane. So we have just seen that I have drawn one line at certain degrees of angles. Here, if this object is cut from this side, so we should plot this section line at the cut section view. So these lines are usually drawn with a lighter grade of pencil. These are usually drawn with the 2H pencils. These are known as section lines. These are usually spaced at equal distance, and these are usually drawn at 45 degrees to each other. So now let us see section line in practice. So which is the correct practice to draw a section line? So always remember, space between lines may vary from 1.5 mm for small sections to 3 mm for a large section. So like this, we can take examples. If the section is small, we can take the difference between these lines as 1.5 mm. If the section length or the size is more, we can take the difference between the line as 3 mm. There are some common mistakes which are observed in your examination. So what we should omit in our drawing. So we should keep in mind we should not make this kind of mistakes in your examination. So don't try to draw freehand lines and too much close lines like this, which is shown here. Don't try to draw the too much distance between the two lines, it looks bad. Then after, don't try to draw the uneven distances between your lines like this and the darker and lighter lines. And finally, you should not draw this kind of very narrowly, very closely drawn lines. So you should not follow these mistakes. You should follow the drawing on the left hand side. As you can see, the distance between the lines should be very uniform, either 3 mm for the larger section or the 1.5 mm for the smaller sections. Now let us move ahead. Section line in practice 2. So what you should give? It should not be drawn parallel and perpendicular to your contour of the view. So lines should not be parallel and perpendicular to your contour of the view. So this is our object, and you can see that I have drawn the line at particular different angles other than lines used to the drawing for construction. So we should always draw the lines which are of the different angle other than the lines which are used to construct that element itself. So common mistakes which are found here is, now suppose this is the object and it is constructed by the use of horizontal line somewhere. So you can't plot this line with the horizontal lines which is parallel to one of the lines which is used to generate this object. You can't use this lines because it matches the contour of the object, and obviously you can't use the lines which are parallel to this line because this line is already used in order to construct this element. You can't use the lines which are used in order to construct the element. You should choose any random angle which is very different than your contour of the object, either your particular lines which are used to generate your object. So always keep in mind, you should be taking another different angle to construct your section lines. Then after, types of sectional views. So we have a few types of sectional views available. So first is a full sectional view. Second is offset sectional view. third is half sectional view, and the fourth is a broken out sectional view. But don't worry, into your examination, most of the times it is asked that you should find out the full section view of an object. So now let us move ahead and let us see one of the examples on full sectional view. So let us suppose this is a full sectional view. So in view, the view is made by passing the straight cutting plane completely throughout the part. So in which we will be having one element and we will be cutting that object throughout from its length direction, and we will be having that element cut. So let us take one element. So this is the element. Now I will try to cut this element by a sectional cutting plane. So before that, this is your top view of an element and this is your front view of an element. So this is the type of which the element looks like. So as you can see, there are a number of hidden lines here. So when we try to cut this object like this, so it will cut throughout your object like this. Then we need to remove the front portion of your object. So let us remove the front portion. Now you can see there are a number of details which are hidden, which could not be seen if we take this front view normally. So now you can see there are very important details which are hidden inside your object. So after cutting this object, we can clearly understand the object. So after that, we should eliminate the hidden lines from here. So let us eliminate the hidden lines from here. And when we eliminate the hidden lines, it is replaced by your hatching lines here. So whenever the material is cut, we are placing the hatching lines. So this is how the full section view works. Then we should put the section line here in order to say that we have cut our object from this particular portion, right? So now let us move ahead and let us see the second type, the offset section view. So in offset section view, the view is made by passing bended cutting plane completely through the part. So in previous case we have the flat single plate which cuts the object. In this case we are having the bend plates which is bent at certain places, and we are using that plate in order to cut our object. So let us see one example. So this is our object and these are a few views. This is the top view and this is the front view of the object, as you can see. Now we will be using one plate. So you can see this place is bent at the two places. So it is not a complete flat plate. So we will be using this bent plate. So whenever you are using this kind of bent plates and you try to cut the object, this is nothing but what your offset sectional view. So let us try to cut this object. So now we have cut the object. So as you can see, this is the cutting plane line. So when we try to cut, this is the cutting plane line, which is the offset cutting plane line. So now what we need to do? So now you can see that there are a lot of details which are hidden, shown here by hidden lines. So what we should do? So we should remove the front portion of that object like this. Now we can see there are a lot of details, and with more clarity we can now observe the object. So now let us apply the effect of that section on this line. So we should be removing the dotted lines here and we will be placing the hatching lines. So this will be the final sectional view of that object. So now here, one thing is to remember. So always remember, you need not to show the edge views of your cutting plane here. So as you can see, these are the cutting planes. So you need not to show these lines of cutting planes onto your drawing, because we are concerned with our object, not the cutting plane. Cutting planes are used in order to just cut the object, not used to just draw the lines of the cutting plane in the views itself. So always remember, you need not to show the edge views of the cutting planes like this shown by the eight lines. So now let us move ahead and let us see how to give the treatment to these cutting plane lines or hidden lines. Hidden lines are normally omitted from the section. So what we are doing actually while we put the cutting plane line into the object. So let us take one object. So this is my object. And these are two views, this is the top view and this is the front view, and these are the hidden portions. So let us observe the effect when I try to cut the object, and what is the effect on these hidden lines. Let us observe. So now let us try to cut this object. So here I am cutting this object from this direction. As you can see, this is my cutting plane line. So let us remove that object portion. So now you can observe the internal part of your object. So when we try to observe this object now from this direction, then we can have a different view generated, which is nothing but your sectional view. So when we are cutting the object, we will be converting this dotted line into the full lines, as you can see, and we are showing the remaining portion by this hatching line. But remember, the certain portion of the lines is still hidden behind this part. So you can see there are certain portion of object which are still hidden behind this part, which should be shown by the dotted line. You need not to draw each of the parts of your solid by a hatching line, because certain portion of lines which are hidden on the back side of your object. So let us suppose if we try to cut this portion, so this front portion would be removed. So this portion is shown by this portion. But the line which is behind this portion is this line. So this point generates one line. So this is one line which is dotted. So when we try to take the view from this direction, this line can't be seen because it is the back side of the portion. So that's why this line is made dotted. And similarly, when we try to observe this portion, so this is the portion, but back side of this portion would be this point. So there will be one line passing from this point. So this line corresponding to this point would be dotted. So it is not always possible that when we are using the cutting plane that each of the dotted line will disappear and you can have your object with clear solid lines and with edging. So always remember, you should keep in mind that whichever part you are cutting, if that part is having the dotted line, it can be removed, but the part behind that part is still not seen. So you should keep that dotted line intact in that position. This is the treatment, how we can give the treatment to your normal object by giving the sectional views, right? So now let us move ahead. So half sectional view. So now, what is the half sectional view? View is made by passing the cutting plane halfway through an object and removes the quarter of it. So in this case, what will you do? It is just like a pizza. So if you have a pizza and you are cutting the quarter of the pizza by going half of the pizza to the center and coming back from another half, so you can have the quarter section cut from the pizza. So it is just like this. So let us understand by one of the objects. So we are having one object. This is our object. So let us take two views. This is the top view and this is the front view of an object. So this is the view. In front view you can see there are a number of hidden lines. So now let us try to cut this object like this. So observe the procedure. So this is the quarter plane. So we are cutting the quarter means the one-fourth of your object. So it is known as a quarter. So we are cutting the 25% of your objects or one-fourth of the object. So this is how we can cut. So after cutting this object, we will be having this cut portion removed. So it is a quarter portion or one-fourth portion is now removed. So in the front view you can see the section now. So now when you try to observe this image from this side, so on the left hand side portion would be removed. So you can see the section view on the left hand side of your observer. So you will be having this portion on the left hand side, and on the left hand side portion would be made by removing the dotted line, and you should give the hatching line to that. But always remember, when you try to give the hatching to this portion, these portions dotted line will disappear. So let us observe the process. So when we try to give the hatching to this portion, so this portion of dotted line will be removed. So always remember, in your half section view, one of the side would be sectional and another side would be without section or without any dotted line, because these both the sides are identical, and in the first half section view we can get all of the details of that object. We need not to specify the lines on another part. This is a special case in which we will be defining the left hand side portion as a sectional view, and right hand side portion, all of your hidden lines would disappear. So always remember. So this is known as your half sectional view. Now let us move ahead. Let us see the broken out sectional view. The view is made by passing the cutting plane normal to the viewing direction and removing the portion of an object in front of it. So how we are doing it? So it is just like if you want to see a certain portion of an object to be revealed. So what we need to do? So let us take one object. So this is my object, and these are its views. This is the top view and this is the front view. So now let us observe this object from this direction. This is the direction of the observer. So this will give you the front view like this. Now let us suppose if we need to just remove a certain portion of the object, and we should see that what is behind that in the certain portion. So what we need to do? You should take one plane perpendicularly observes direction at that place, and you should cut it by one of the hammers or something like this. And when you try to remove that certain portion, you can actually see the internal details of that particular portion. And by giving the details to that particular section, so you need to just first construct this line. So this is your cutting line. So this is your cutting line, or this is your section line. And after having this line, you are removing this portion and you are revealing this certain portion. You should give the section to that particular portion only, not giving the section to your whole of the object. So this is known as a broken out section. So many times it happens that we should just focus on particular part, not all of the object. We'll be using this kind of section, right? So now let us see the comparison of the sections, different sections that we have just learned. So let us see. So comparison of among the several section techniques. So this is our object and this is its top view and front view. Now we are using a method. It is your what? Full section view. So we'll be cutting by a plane, cutting the whole of the objects. We'll be having these views generated. These are nothing but the views generated. now we'll be using the half section view. So we are cutting the quarter of the portion of this object like this. We'll be using the 1/4 portion like this, and we'll be having this view generated like this. So this is the way we will represent it. And finally, we are having the broken out section. So we need to decide which section we need to highlight or we need to reveal the details of. We should put that section in perpendicular to visibility direction. And we should give hammer or something like that. We should cut that portion, and we'll be having this particular portion removed at that place. And we'll be having the final generated. Then we can reveal the details of that particular portion or section. Right? So it is very easy. It was a comparison between each of the methods. Now let us move ahead and let us see the dimensioning of the section. So let us suppose if we know the sectioning now, and now we need to give the dimension of that section, then how would we give the dimension of that section? So now let us see. So now, in the most of the dimension cases, the sectional view also follows the normal rules of dimension. So first is a poor dimension and second is a good dimension. So let us see the difference between these two. So in first view you can see that we are giving the dimension to the dotted line. So always remember the clarity of an object in dotted line is not so much clear because we can't understand which portion is showing which element. So always remember we can't give dimension to the dotted line. So you should give the dimension after taking the sectional view of that object, and you should make each and every portion visible, and you can only give the dimension to the visible portion of an object like this. So after cutting the section, it is having a more clarity, whichever place we are having the material, whichever places we are not having the material, we are having the holes which can now be clearly defined. We will be having centers of the circles as well. So now you can define each of the places very easily. Then after, second, if we are having this kind of situation in which we are having circles, you can't define the location of the circles in the case of this dotted lines. You should be using these section views like this, and after getting the section view now you can clearly define the places because it is with more clarity you can see that as compared to your previous example. So we can now give the dimension to this drawing. So always remember we can't give dimension to any of your dotted lines in engineering graphics, right? Or engineering drawing. This is a good practice to follow, and the first one is to follow. So if you in examination, if you are giving dimension to the dotted line, it is not accepted, always remember that. So now let us move to first object. So this is suppose the object asked for the examination. So what is your task? So here we need to just observe this object from the two directions. First the front view direction and second the top view direction. Then after you should take the sectional views. So it is said that there are two section lines are shown. First is shown by the A line passing from the length of your object, and second line is passing a BB line which is showing from the width of the object. So first let us draw the top view. So by using the orthographic concept, we can draw this top view like this. By observing the object from the top view, we need to just draw the top view. Then after we will be drawing the front view of the object from this direction. So let us draw the front view from the orthographic projections concept. And then after we should be cutting this object from the center because it is said by A line, you can see it is passing from your center of the object. So it is saying that you should cut your object from this place. So you should cut your object by cutting it from this place, and after cutting the object you will get this final view generated, and which is nothing but your sectional front view. And it is also known as elevation. You can also call it as a sectional elevation. Then we will be observing this object from the left hand side direction. We are trying to find the left hand side. So let us observe the object from the left hand side direction. You should plot the object by according to your orthographic position. Then after it is said that it is cut by this B line. You should cut the section from this BB line. You will be having your sectional side view in the left hand side as you can see. So you will be plotting all the sections onto the side view into your object. But remember, here I have not drawn the sections into these triangular portions, also in the image also. So always remember, this is known as a rib or the supporting element, and we never keep hedging this rib or supporting element. Because these are the elements not a part of an element, but these are the elements which are used in order to just support the object or to prevent it from bending. These are the elements which are just for the supporting purpose. The edging is not needed in this kind of elements. We are not providing edging to this triangular portion which are known as rib. Right? That is all from my side. If you have any doubts, any queries, feel free to comment down below. And if you have enjoyed my lecture and teaching style, do not forget to like, share and subscribe to my channel. Keep learning, stay connected. Bye bye.